Good morning, dear students. So, in order to continue our discussion about the matter, we'll discuss about the properties or characteristics of particles of matter today. As we have discussed in our earlier lecture, that anything that we can see around us, we can touch, which has got mass and which occupies space will be considered as matter, right? And if you look at the characteristics of matter, then you find that the matter is particulate. Particulate means it is made up of very small particles. These particles may be atoms, molecules or ions, about which we will be discussing in our later lectures. So today what we are going to discuss is about the characteristics of particles of matter. We have seen that all matter is particulate, made up of particles, and now we are very curious to know about that what are the characteristics of these particles of matter. So if we look at the characteristics of these particles of matter, first of all we find that these particles are extremely small. They are so extremely small, you can say they are small beyond our imagination. We can't even compare that how small are these particles. As we have discussed in last lecture also, if you keep on breaking a piece of chalk, you keep on breaking and breaking and breaking, and then you will reach to a very small particle. Maybe the particle is so small that it is not visible to our naked eyes, right? So we can say that all matter is made up of particles, and these particles are small beyond our imagination. So in order to show that how small are these particles, here we have an activity. Suppose we have a beaker. In this beaker, suppose we take around 1 liter of water. In this 1 liter of water, you can add few crystals of potassium permanganate, or you can add few crystals of potassium dichromate. Let me tell you about potassium permanganate and potassium dichromate. Potassium permanganate is a chemical which is available in solid crystalline form, and it is having very intense violet color. It is so intense that it almost appears you to be bright shining black like color. But if you dissolve 1 or 2 crystals of water, this potassium permanganate in water, the whole water becomes very dark pink, or sometimes it becomes so dark that it appears like purple in color. On the other hand, potassium dichromate is same type of compound, but it is having an orange color. So let's dissolve some crystals of say 1 or 2 crystals of potassium permanganate in 1 liter of water, and you will observe that whole this solution, this turns pink or very dark pink in color, right? Now take another beaker, and in this beaker you take 900 ml of water, right? And from beaker 1 you transfer 100 ml of solution, 100 ml of solution from first beaker, and again you will observe that the solution in beaker 2 also becomes pink in color, right? Take one more beaker, another containing say 900 ml of water, and transfer again 100 ml of solution from beaker 1. And what you observe? Again you see that the solution in beaker 3 is again pink in color, right? You keep on repeating the same phenomena number of times. Number of times you carry on the same activities, maybe 4 or 5 times or 6 times, and you will observe that every time the solution of this beaker is becoming pink in color. Maybe the intensity of the pink color is little less. It is possible that first solution was very dark pink, another was light pink, another one was even lighter pink, but every time you get the solution to be colored. Why? The first solution was colored because the crystal of potassium permanganate we have added here has broken down into number of smaller particles, and all these particles were evenly distributed, right? So you can say that color of the solution is because of the particles of potassium permanganate. When you transfer this solution to another beaker, some of the potassium permanganate particles from beaker 1 are shifted to the particles of beaker 2, and again the solution of beaker 2 became colored, right? Again, when you transfer this solution to beaker 3, some of the particles of beaker 2 were transferred to beaker 3, and again the solution of this third beaker was again pink in color. How this could have been possible? This could have been possible only because of the reason that the crystals of potassium permanganate, they contain very tiny particles. If these particles would have been large in size, if they were big in size, the number of particles in one crystal would have been very small, and you would not be getting the repeated number of times the solution to be colored, right? So this activity gives you a clear indication that particles of matter are small, so small that they are beyond our imagination. Like even if I put a dot of chalk here also, this small dot of chalk, can you imagine how many particles would be there in it? No. There are, you can say, millions and trillions of particles in this one dot of chalk, right? So we can say that particles of matter are extremely small in size. Now look at another property of particles of matter. So we can say that these particles have a space between them. Right? And these spaces are known as interparticle spaces. So particles of matter have got spaces between them, and these spaces are known as interparticle spaces. That is another thing, that in some matter these spaces are very large in size, whereas in others these spaces are very small in size, right? So, but there are spaces between them, and this we could have proved with the help of activity that we have discussed in our earlier lecture. As you have seen, when we took some amount of water in a beaker and you mark the level of water and then you add here sugar or salt. So what you observe? You didn't observe any change in the water level. Reason? Because whatever sugar or salt you have added here, it has occupied the interparticle spaces, and because of that occupation, you don't get any increase in the water level of this beaker. So this activity proves that particles of matter have a space between them, right? So now we have another property about these particles. And what is that property? That particles of matter attract each other. All these particles of matter, they have tendency of attracting each other, and this force of attraction between the particles of matter is known as interparticle force of attraction, or the same interparticle force of attraction is also known as cohesive force. So all these particles of matter which are extremely small in size, that have got space between them, but again these particles of matter, they attract each other. In some cases this force of attraction is very strong, in some cases that force of attraction is weak. So the nature or the extent of force of attraction varies from matter to matter, and based on that only the matter is further classified into three states of matter, that is solid, liquid and gas, about which we will be discussing in our next coming lectures, right? But right now there is a very interesting fact that all these particles, they have got some force of attraction. And as I have said that these force of attractions, they vary from matter to matter. Like again, if we have a piece of chalk, if I am going to break it, it is easily broken down. Why? Because the force of attraction between these chalk particles are very weak. Instead of this chalk, if you take a wooden stick or if you take a plastic stick and you try to break it down, yes, you will have to work a little harder. In that case, it will be broken down, but not as easily as in this case of chalk. The reason? Because the force of attraction in that case, your chalk was weakest, but in the case of a plastic rod or a wooden stick, that was comparatively stronger, and these forces will not be easily broken, right? And instead of that, if you take a piece like a rod of iron, it doesn't matter that how strong you try, but ultimately that rod is not going to be broken down, because the force of attraction here are very, very strong, right? So we can say that the particles of matter, they attract each other, and this force of attraction is known as interparticle force of attraction, or also known as cohesive forces. But the extent or the strength of these cohesive forces, they vary from matter to matter. Now I will go back to the activity that we have discussed in earlier lecture. As you must be remembering that in earlier lecture I have given you an activity where what you have done, you have taken some water in a beaker, mark the level of water, then you have added here the sugar or salt, and you didn't observe any change in the level of water. At the same time, to prove that all that matter is made up of particles. At the same time, you can also have, as I told you, you can put a piece of wood or iron, and in that case, you see that the water level increases. Why? At that time I asked you, what does this mean? Does this mean that iron is not made up of particles? No, it is made up of particles, but the problem here is that the interparticle forces in iron are so strong that even by adding in water, these interparticle forces are not breaking down. And that's why this iron cube or iron piece is not getting separated into the separate particles, and these particles are not able to get distributed in the interparticle distances or interparticle spaces of the water, right? So that's why if you put a block of iron or if you put a block of wood, the water level does not remain same, it increases, because Don't get confused that it shows that iron or wood is not made up of particles. Iron as well as wood, everything is made up of particles, but you are not getting any change in the water level because, yes, these particles are held together by a very strong force of attractions, right? Another important property of particles of matter here is that these particles are continuously moving. Okay, one more thing before discussing about this aspect. Let's talk about, as I have told you, that the particles of matter have got attractive force between them, and these force of attractions are known as cohesive forces. At the same time, there are some other type of forces, attractive forces, and these are known as adhesive forces. So what is the difference between cohesive and adhesive forces? The cohesive forces are the force of attraction between the same type of particles of the matter, right? Like the force of attraction between chalk particles, the force of attraction between iron particles, the force of attraction between water particles, these are known as cohesive forces. Then what are adhesive forces? So adhesive forces are the attractive forces between particles of matter of different types. So these are adhesive forces, right? For example, you must have seen when you put some water on the glass surface or something, that surface is wetted, right? Why that surface is wetted? Because there is an adhesive force between water and the glass surface, right? But instead of that, if we put some drop of mercury on this glass surface, you don't see the surface of the glass getting wetted by mercury, although mercury is also a liquid. Why? Because in this case, the cohesive forces between mercury particles are so strong that it is unable to develop any adhesive force with the surface of glass. That's why mercury does not give you any wetting effect with glass or any other surface, right? So now coming back to the another property of the particles of matter, that particles of matter are continuously moving. These particles of matter are not fixed at their position, they are continuously moving. Again, depending upon the nature of matter, the particles of matter may be moving fast, may be moving slow. So again you can have an activity. If we take some water in a beaker and you add a drop of ink in it. So we have added a drop of blue or red ink to this water. You will observe as soon as you add ink to the water, within no time the whole water is turned colored, right? Why? Because the particles of ink have very quickly mixed with the particles of water. And this is possible only because the particles of matter are continuously moving, right? So this property of moving of the particle is given another name, and that is known as diffusion. So what is diffusion? How we define diffusion? Diffusion can be defined as intermixing of particles of matter on their own. So this property of intermixing of particles on their own is known as diffusion, right? So these all are the properties or the characteristics of the particles of matter. So now we can summarize the whole thing that we have discussed in this lecture. So the first of all matter is made up of particles. These particles are extremely small in size. They have got spaces between them. They attract each other, and that force of attraction is known as interparticle force of attraction, or also known as cohesive force, right? And all these particles of matter are continuously moving from one place to another, right? So in our next lecture, we will be discussing about the classification of matter to different states of matter. Goodbye till then.